Previously on this channel, we explored a discovery that stunned the scientific world. The James Webb Space Telescope may have detected signs of life beyond Earth. Its instruments picked up traces of a rare molecule called DMS in the atmosphere of a distant exoplanet, K2-18b. On Earth, this molecule is only produced by living organisms, tiny life forms like bacteria and phytoplankton, which means K2-18b might be more than just another planet. It could be alive. While further study is needed to confirm the findings, this discovery has brought us closer than ever to answering one of humanity's oldest questions. Are we truly alone in the universe? Okay, what if K2-18b really does harbor life? About 10% of exoplanet discoveries spark this kind of feverish debate, and K2-18b is no exception. Here are some wild but plausible scenarios. Scenario 1. Microbial life. If DMS is a biosignature, K2-18b might host microbial life. Simple organisms like bacteria or plankton thriving in liquid oceans. These microbes could be producing DMS as a byproduct, just like Earth's phytoplankton. But they'd be adapted to a high-pressure, hydrogen-heavy world, unlike anything on Earth. Imagine tiny life forms glowing under a crimson sky, utterly alien yet eerily familiar. Scenario 2. Exotic chemistry. What if DMS comes from geology, not biology? K2-18b's intense pressures and temperatures could drive chemical reactions we've never seen. Volcanic activity or deep-sea vents might churn out DMS without any life involved. This wouldn't rule out life. It'd just mean we need to rethink what biosignatures look like on alien worlds. Scenario 3. A false positive. The least exciting but still possible outcome. The DMS signal might be a fluke, noise in the data, an instrument glitch, or an unknown molecule mimicking DMS could fool us. Webb's observations are pushing the limits of what's possible, and false positives happen. If this is the case, K2-18b is still fascinating, just not a home for life. Scenario 4. A new kind of life. Here's a wild card. What if K2-18b hosts life, but not as we know it? Life based on different chemistry, like silicon instead of carbon, or thriving in liquid methane, could exist. DMS might be a byproduct of something we can't even imagine. This would force us to rewrite the rules of biology, opening our minds to life's infinite possibilities. Why does K2-18b grip our imagination? It's not just the science. It's what it means to us as humans. The idea of life elsewhere taps into our deepest questions. Are we alone? Is the universe teeming with others? Every hint of a biosignature sends our hearts racing because it challenges our place in the cosmos. Our brains are wired to seek patterns and meaning. A molecule like DMS isn't just data. It's a story, a possibility. Like ancient explorers scanning the horizon for new lands, we're drawn to the unknown. The power of suggestion plays a role too. Headlines screaming alien life prime us to see K2-18b as a turning point, even if the science says maybe. That's why K2-18b isn't just a planet, it's a spark. It reminds us how much we yearn to connect with something bigger, something out there. Even if it's just microbes, the discovery would be monumental, a bridge between us and the stars. So what's the verdict on K2-18b? For now, it's a cosmic maybe, a world that teases us with hints of life but keeps its secrets close. The DMS signal, the water vapor, the habitable zone, they're pieces of a puzzle we're only beginning to solve. Most likely, it's a fascinating planet with exotic chemistry, but the chance of life, however slim, keeps us glued to our telescopes. K2-18b isn't just a dot in the sky, it's a challenge to our curiosity, a call to keep searching. The universe is vast, and every clue brings us closer to answering the ultimate question. Are we alone? Next time you look up at the stars, think of K2-18b, a world that might just hold the key to our place in the cosmos. Subscribe for more cosmic mysteries, strange worlds, and the science that's rewriting our story in the stars. Where will we go next?